modification of oil in water, lecithin-based emulsions with a phospholipase A1. Ruby, go ahead and please share your presentation, and the stage is all yours.
Thank you. Do you see already the presentation?
Yes.
Yes.
Thank you. Well, good afternoon. My name is Dely Rubi Chávez Garay, and I'm a PhD student at the Faculty of Chemical Science, and I've been working in the past years with enzymes and its application in food. So today I'm going to talk about phospholipase, specifically about a phospholipase that has been used to modify an oil-water lecithin-based emulsion. So as a brief introduction, we have that the biological role of phospholipase in living organisms are fundamental because they play a crucial role in the metabolism and synthesis of phospholipids. But what happens when those phospholipids are used in the food industry to modify or improve characteristics of their own foods? Like this is the such is the case of the phospholipase that has been used in the industry of vegetable oils, in the deguming process, or in the modification of egg yolk, lecithins, emulsion properties, and most recently in bakery and dairy products. So we have two characteristics in bakery industry that they are looking for elevate the low volume and bread softness, and in the dairy products, raising the cheese yield. One thing that is really important about phospholipids are that they, of course, hydrolyze phospholipids. We have some of phospholipids like A1, A2, B, C, and D, and they're on all they are used to hydrolyze phospholipids. The difference is that they are attaching different bonds in the phospholipid structure. We have aquí a schematic representation of a phospholipid. So for this work, I work with phospholipase A1. So I'm going to show you how it works. We have the phospholipid and the phospholipase, and of course we have to have presence of water. When this happens, we can gel a lysophospholipid plus a free fatty acid. So this is the way that the phospholipase works, and the principle or the importance of phospholipids in the food industry is mainly because they are good emulsifiers. And this characteristic of conferring emulsifying, wetting, and self-assembly characteristics are because they are amphiphilic structure. Also, in the same image, I have the structure of phospholipid. We have an polar section and a non-polar section. This is the characteristics of an amphiphilic structure. Even when the phospholipase have hydrolyzed the phospholipid, we have a lysophospholipid with the same characteristics of an emulsifier, but even are more hydrolytic than a phospholipid themselves. With this in mind, and despite phospholipids are currently used in different industrial processes it's not clear the effect that these enzymes have on food, mainly on lecithin-based emulsion. However, it can be hypothesizing that phospholipids are able to hydrolyze phospholipids arranged in oil and water emulsion, modifying consequently the stability of emulsion. And it's because the aim of this study is evaluate how a phospholipase type A1 have the capability to hydrolyze phospholipids arranged in an oil and water emulsion with different droplet size distribution. It's in here I am presenting you my experimental strategy. So as you see, we elaborate 4 different emulsions with 2 different methods. 2 of the emulsion that we get from mechanical steering at 2,200 revolution per minute, and the other at 15,500 revolution per minute. All the emulsion were made by oil, lecithin, and water, and the other 2 emulsions were elaborated with an ultrasound, applying high power ultrasound. And after each of these emulsions were elaborated, we add a phospholipase A1 and incubate at 40 degrees Celsius. And before, during, and after the enzymatic reaction, we evaluate our samples using different techniques like just simple visual observation, optical microscopy, rheology test, enzymatic assays, and thin layer chromatography. As a result, I want to show you this figure where where we see the appearance of each emulsion. For example, for make easier my presentation, and because the name of my treatments are wide, I'm going to name as treatment 1 for this treatment with mechanical induced emulsion at low energy. This mechanical induced emulsion at high is going to be 2, and etc. So you can see the difference between 1, 2, 3, and 4. For day 1, without the phospholipase, we see in mechanical induced emulsion, we see an yellow and opaque color, and whereas the ultrasound induced emulsion have a milky opaque color. So it's really clear the difference between them. And when we add the phospholipase, and after 7 and 30 days, we see a really difference about the stability of our emulsion. We see in mechanical induced emulsion, after 7 days, a clear separation of our phases. And of course, 30 days, we see that separation also in the treatment number 2. So also we see, even if we have an important separation of phases in mechanical induced emulsion, we don't see that aspect in the ultrasound induced emulsion. We also characterize some change in viscosity of each treatment, treated or not with a phospholipase A1. And you can see that at the initial viscosity, we don't see so much change between the time 0 and 1 hour after. But we can see a difference between the control, which is as emulsion not treated with the phospholipase, we see the difference between control and all those emulsions treated with phospholipase. And it's more important that when we see that difference, that also is the same like the picture that I showed you before. It's clearly visual differences, but also in the viscosity, we can see also the difference. About the enzymatic activity in each emulsion, we are seeing that the rate of free fatty acid released in each emulsion, we took that characteristic to evaluate the enzymatic activity. So we see that 1 and 2 treatment are those that have the highest rate of free fatty acid release, and comparing with the ultrasound induced emulsions. By the time that we was taking the enzymatic assay, also we took aliquots to evaluate how the hydrolysis take place during 30 minutes. We took aliquots at 5, 15, and 30 minutes, and we see the difference on each. I'm showing you that clear difference where phosphatidic acid and phosphatidyl ethanolamine are hydrolyzed after the time. And we see that like a clear diminishment of the bands in all treatments. Mechanical, those are from mechanical induced emulsion, and those are from ultrasound induced emulsions. And for all, phosphatidic acid and phosphatidyl ethanolamine are the more hydrolyzed. We see also that response in the part of lysophospholipid region, where also the band increase the color for each phospholipid. The same thing happens in all the treatments. So as a conclusion, it was evidence that phospholipase can hydrolyze lecithin phospholipids aggregate in emulsions. However, the hydrolysis of phospholipids by the phospholipase depends on the size of the emulsion droplet. The bigger the enzyme, the higher the enzymatic activity, and in consequence, the emulsions having lysophospholipids were more prone to flocculate and coalescence than phospholipid-based emulsions. So this is the end of my presentation. If you have any questions.
Thank you very much, Ruby, for the presentation. Very neat. And as you say, we have some time for some questions, so please go ahead.
I do have a question. Hi, Ruby, how are you?
I'm fine, how are you?
It's good to hear from you.
Nice to meet you too.
What is the next, what is the implication of the modification of those phospholipids? I mean, in terms of, can you use that in a formulation? Can you use this one as, how is the final use of this product?
So the importance of this is that we can have an enzymatic modification in an emulsion and at the same time have a lysophospholipid. So we are looking for phospholipid, to real phospholipids, because those are more, those have the emulsifier characteristics more increased. And if we have an unstable emulsion with a phospholipid in a normal way, we can have a better stability in our emulsion that have lysophospholipid.
What about the health claims? Is there any health benefit on phospholipids?
What is the word that you use?
Health benefits. I mean, is there are nutritional benefits of using phospholipids?
Well, we have not seen that like the benefits for the consumption of for I don't know, a beverage or something, because we know that phospholipids in food are relevant in the health, but we didn't take that way like a health benefit. Did I answer your question?
Yes.
Thank you.
Any other question from students?
No more questions. Seems like everyone is hungry, probably.
I have one question.
Go ahead, Govinda.
Okay.
When you use the ultrasound, is there any structural change or molecular change in the phospholipase because of the high temperature produced by the ultrasound?
Can you put in some other words your question, because I didn't get it so much.
Well, you said that you use ultrasound with and without phospholipase, right?
Yes.
So is there any chance, because of the high temperature produced because of ultrasound, is there any chance that phospholipase might have changed its structure that could have affected your the result that you are getting?
Well, we try to avoid that thing with using a chamber, and that chamber have like a jacket. We pass through cold water, and we maintain our temperature below 40 degrees. So we try, in that way, we didn't change the structure of phospholipids with the temperature more than the phospholipase.
Got it. Thank you. Thank you for your answer. That was a good presentation.
Thank you. You're welcome.
Any other questions? Well, I don't hear from anyone, so I think we are right on time, 12:30, to conclude the first session of this seminar, the program, and we are going to have a break, lunch break, and we are going to be back at 3 p.m. Please, the organizing committee, correct me if I'm wrong. I think it's 3 p.m. where we all are going to be back for the second session on valorization of waste and byproducts.
Yes, at 3 p.m. Yeah.
Okay. Thank you.
Thank you, everyone. Thank